Hello students, welcome to the second lecture on unit and measurement. Right? In last lecture we were discussing about different types of unit system. In fact, we have discussed 4 different types of unit system. So on chapter number 2, unit and measurement, and in this chapter we have discussed about different types of unit system. If you remember, the first unit system was FPS. The first unit system was FPS, that is foot, pound and second. Foot is for measurement of length, pound is for measurement of mass, and second is for measurement of time. Remember here, FPS was introduced by British unit system. It is known as British unit system because Britishers were the first to introduce such unit system. The drawbacks of this unit system was it is difficult to convert, let us say, a unit of length from foot to meter or centimeter, in the same way for unit of mass from pound to kg, kilogram or gram, right? So this system fails, right? The second unit system was CGS, and along with that the third one was MKS. Still we are using CGS and MKS unit system. C for centimeter, that is measurement of length, G for gram, measurement of mass, and S for second, measurement of time. M is for length, that is meter. Remember, M is not for mass, M is for measurement of physical quantity, length, right? And its unit is meter. So M for meter. K for measurement of mass, that is K for kilogram, it measures measurement of mass, and S is for time, that is second, for measurement of time. So still we are using this system because it is quite easy for us to convert meter into centimeter, gram into kilogram, and so on. The fourth system which was introduced was MKSA. Well, again, M is for measurement of length, which is meter, K is for measurement of mass, which is kilogram, S is measurement of time, that is second, and A is here measurement for electric current, which is ampere. Right? These were the 4 unit system which we have discussed. There were drawbacks for all these 4 unit system is that maximum you can measure 4 physical quantities or 3 physical quantities. We cannot measure temperature by using any of this unit system, as well as we cannot measure intensity of radiation and so on. So scientists throughout the world had a conference in France in 1971 on weight and measurement, right? The main agenda was for weight and measurement to decide some minimum number of physical quantities, to select some minimum number of physical quantities, right, for a new SI unit system, for a new system, unit system, and from that we should be able to measure the rest of all the physical quantities, or give unit to the rest of all the physical quantities. Not only that, they have to decide some minimum number of physical quantities to give an appropriate symbol, abbreviation and unit for those physical quantities. Initially 6 physical quantities were selected, and later on one more physical quantity was added. So there are 7 physical quantities in this new unit system, which is known as, in France you can say that it is système internationally the units, and for us we'll call it international unit system of unit, which is known as SI unit system. Right, so this is our SI unit system which we are following now. It has 7 physical quantities. It contains 7 physical quantities. So let us make list of those 7 physical quantities. So we'll give name as SI unit system over here, heading SI unit system. Now we'll exam this question, may be asked for 2 marks. Write note on SI unit system. So you will start from scientists throughout the world had a conference at France in 1971 on measurement and weight and measurement. Right, the main agenda for that was to select the minimum number of physical quantities and to give their proper units, abbreviation and symbol. And based on that 7 physical quantities, we should be able to give units and symbol for rest of the physical quantities. There are 7 physical quantities in SI unit system, and then you have to draw this table. So let us draw the table for SI unit system. Here we write SR number, then name of physical quantity, its unit and symbol. So the first one was, we use this 4 only, first, second, third, fourth. First is for length. Remember, length means length, height, distance, everything. So length. Unit for length was given as meter. The SI unit for length is meter and its symbol is small m. The first physical quantity was length, its unit is meter and the symbol for unit is small m. Now the second physical quantity was mass. That is kilogram, unit is kilogram, SI unit is kilogram and symbol is kg. So the second unit is mass, so the second physical quantity is mass, its unit is kilogram and symbol is kg. The third physical quantity is time. Unit is second and symbol is S. So the third physical quantity is time, its symbol is S and the unit is second. The fourth one is electric current. Now remember, here students generally write current. Right? Current is wrong, you have to specify electric current because the meaning of current will be different depending on the situation. Say for example, what do you mean by current? So current is anything which is flowing is known as current. Anything which is running is known as current. Say for example, if water is flowing, then we can say that this is water current. If wind is flowing, then we can say that this is wind current. In fact, in day-to-day life, if you wear something and someone will ask you, what is this? Then you will say that this is current fashion. So current means running. This is running fashion, right? So if you are writing current, then that will be incorrect. You have to specify it is electric current. That is flow of electrons. So electric current. So electric current, its unit is ampere and its symbol is capital A. So the fourth physical quantity is electric current. Its unit is ampere and symbol is capital A. Now the fifth one is thermodynamic. The fifth one is thermodynamic temperature. thermodynamic temperature. Its unit is Kelvin and symbol is capital K. Its unit is Kelvin and symbol is capital K. The sixth one is luminous intensity. Luminous intensity, its unit is candela and symbol is CD. While the last one, the seventh one, which was introduced later on, was the seventh one is quantity of matter. You can call this as amount of matter, amount of substance, quantity of substance will do, right? Quantity of matter, its unit is mole and symbol is MOL, right? So these are the 7 physical quantities which were introduced in our SI unit system, which were included in our SI unit system, you can see. So these are the 7 physical quantities. You have to remember all these 7 physical quantities. So let us quickly revise this. The first one is length, its unit is meter and the symbol is m, small m. The second one is mass, its unit is kilogram and the symbol is kg. The third one is time, its symbol is second and its unit is second, and its symbol is s. The fourth one is electric current, its unit is ampere and the symbol is capital A. The fifth one is thermodynamic temperature, its unit is Kelvin and its symbol is capital K. Remember, temperature which we are measuring is in degree Celsius or degree Fahrenheit, but its SI unit is Kelvin, right? Sixth one is luminous intensity. Now, what is luminous intensity? Let us say intensity we will discuss later on, but suppose you can consider, for time being you can say that the brightness can be considered as intensity in case of light. Exact meaning is something different. You can define intensity is the amount of energy per unit area per unit time. The amount of radiant energy incident on the surface per unit area per unit time is intensity. But this we will discuss later on in any another chapter where we will come across intensity. Right now you have to remember intensity is something related to brightness. Say for example, if you have a torch, right, and if you focus your torch on this whiteboard from distance, they will find that the light will be spread out throughout the board. So you can say that the intensity of light is less. Now bring that torch closer to the board. Right? If you bring that torch somewhere over here, you will see a bright spot over here. Right? So that bright spot is brighter than the initial condition. So you can see that this has more intensity compared to the last one. For timing, we will remember like this. Exact meaning and exact definition we will discuss in chapter I think 15. That is in waves, right? So luminous intensity, its unit is candela and CD. And the last one is quantity of matter, mole. Luminous intensity, again I will say that intensity of radiation, luminous intensity, all these things are different and we will discuss in any one of this chapter. That is chapter number 15, I think, right? So these are the 7 quantities which you have to remember and you have to prepare. It can be asked for 2 marks in board examination, right? That write note on SI unit system. Then you have to define that 4 to 5 points which we have discussed. If you want, we will repeat again. A conference was held in France in 1971 in which the scientists throughout the world took part, or you can say that scientists throughout the world had a conference at France in 1971. The main agenda or the main reason behind such conference was to develop a unit system which contains minimum number of physical quantities, yet it can measure all the physical quantities. We can give units and symbols for remaining all the physical quantities. By using these 7 physical quantities, they give units of these 7 physical quantities and their abbreviation as well as symbol. So this was the main agenda of that meeting. Right? They have selected 7 physical quantities, their symbols and unit. and these 7 physical quantities combinedly known as SI unit system, right? So these are the 7 physical quantities. Remember, these all physical quantities which are present in SI unit system are known as fundamental physical quantities or base quantities. So you can say that these length, mass, time, electric current, etc. are our fundamental physical quantities. They are known as fundamental physical quantities or base quantities. They are units. These units are known as fundamental units or base unit. Right. So these are the 7 physical quantities which are also known as fundamental physical quantities. Their units are known as fundamental units. So what are fundamental units? The units of 7 physical quantities which are in SI unit system are known as fundamental units, and those physical quantities are known as fundamental physical quantities. Clear? Now, along with this SI system, a guidelines was provided, or you can say that practical norms were given that how to use this SI unit system. We are going to discuss those practical norms now. Apart from that, some common mistake which we are doing while using this SI unit system, we will discuss now. So the practical norms for using SI system were, the first one is that the symbol of the unit must be as it is given in the table. The symbol of the unit which we are going to use must be as it is given in the table. Right? Say for example, you can see here the symbol for length, unit of length is meter small m. So we should use small m only. Right? What generally we are doing, suppose we are writing 5 meters, so we may write 5 meter. Right? Sometimes we are writing like this, 5 mtr. This is wrong. Actually 5 meter means this is incorrect. If you want to write 5 meter, it should be 5 meter only, 5 m only, not 5 mtr. Or maybe you might have come across, suppose if you want to write 20 second, we are writing 20 sec for second. This is also incorrect. The symbol for second is small s only, so this is incorrect. If you want to write 20 second, it should be 20 second. This should be the value 20 second. This is how we should write. 20 sec second, if you are writing that is incorrect, because the unit for second is small s only. Right? So this is the mistake which we are doing. So the first norm was the unit, the symbol of the unit must be used or written as it is given in the table. Right? This is our first norm for using SI unit system. The second one is that there should not be any full stop. There should not be any full stop in between or at the end of this symbol of a given unit. Right? You should not put any full stop in between or at the end of the symbol of the unit. Say for example, in that case, if you want to write 5 kg, if you want to write 5 kg, then 5 k dot g that is incorrect, or you cannot write 5 meter. This is incorrect. There should not be any full stop in between or at the end of the unit system. Right? You can put full stop only if the statement is getting over. Say for example, I brought 10 kg of rice. Right? Or you can say that I brought 5 kg of rice. Then I brought 5 k dot g dot is incorrect. Or you can write 5 kg dot of rice. This is also incorrect. Right? The statement is continued, right? So you should not put any full stop in between or at the end of the symbol of the unit. So I brought 5 kg of rice, so your full stop should not be there. Or in between this full stop should not be there. But if the statement gets over, say for example my weight is 80 kg. So statement is getting over here. So for that you can put full stop. So my weight is 80 kg. So there you can put full stop. Right? But for a continuous statement, there should not be any full stop in between or at the end of the symbol of a given unit. Clear? This is our second norm. Now, suppose if I will ask you, what is your weight? Then obviously you will say that my weight is 60 kg, 70 kg, 40 kg, anything like that. What is your height? You may say that my height is 170 centimeter or something like that. So if here you will notice, you are saying that my height is 170 centimeter, or you are saying that my weight is 60 kg. We are not writing my weight is 60 kgs. My height is 170 centimeters. So this is incorrect. So this is incorrect. what it should be? My weight is 60 kg, not 60 kgs. My height is 172 centimeter, not 172 centimeters. It means that the unit of a given physical quantity should always be in a singular form. The unit of a given physical quantity must always be written in a singular form. This is our third norm for using SI unit system, right? Practical norms for using SI unit system. The first norm was the unit should be written, the symbol of the unit must be written as it is given in the table, right? The second one was there should not be any full stop in between or at the end of the unit, symbol of the unit. And the third one is unit, symbol of the unit or the complete unit must always be written in a singular form. Now if you see in this table, you will find that some symbols are in small letters, starting with small letters, while some symbols are in capital letters. Now the reason behind this is that if a name of a unit, if a unit is named after the name of the scientist, if any unit is named after the name of the scientist, then its symbol should always be a capital letter. Say for example here, electric current is ampere, capital A, because ampere is name of a scientist. In the same way, you can see that thermodynamic temperature, Kelvin, capital K. Capital K because Lord Kelvin, the unit of temperature is given after the name of a scientist, which is Lord Kelvin, capital K, right? So if a name of a unit or if a unit is named after the name of the scientist, then its symbol should always be a capital letter. But at the same time, you have to remember that while you are writing complete unit, whole unit, then the letter must be a small letter. It should start with a small letter. See here, ampere, we have started with small letter A. Kelvin, we have started with small k, right? So if a name of a unit is given after the name of a scientist, right, or if a unit is named after the name of a scientist, right, then the symbol of the unit must always be a capital letter, while the unit should always start with a small letter. This is our fourth norms, practical norms for using SI unit system. And the last one, fifth and the last one is that units should always be in a single ratio. Units should always be written in a single ratio. Say for example, if we say acceleration of a body. So acceleration of a body is defined as, simply we'll write velocity upon time. Exact definition is something else, but just now we remember that acceleration is velocity over time. So unit of velocity is meter per second, whole over time is second. So meter per second will not do, right? So you should have unit only in single ratio. Only in single ratio means here you should write this as meter per second square. Meter per second square. Say for example, we have any unknown physical quantity. Let us say we have any unknown physical quantity which has unit Newton per meter per kg per second. Right? Some unknown physical quantity x has unit Newton per meter per kg per second. So this is ratio of ratio. So this is how we cannot write. In this way we cannot write the unit of a given physical quantity. It should have only one ratio, single ratio. So what here we have to do? This will be equal to Newton second upon kg meter. You can write like this. So this will be the unit for this x. This is incorrect, right? This one will be the correct way to write the unit. So the unit must always be written in a single ratio. These are the 5 norms for using SI unit system. So let us quickly revise those 5 norms for using SI unit system. Practical norms for using SI unit system. Now the first one is the symbol of the unit must be written as it is given in the table. The symbol of the unit must be written as it is given in the table. The second one is there should not be any full stop in between or at the end of a unit. Symbol of a unit. There should not be any full stop in between or at the end of the symbol of a given unit. The third one is unit should always take a singular form. Unit must always be in a singular form. The fourth one is if a unit is named after the name of a scientist. If a unit is named after a name of a scientist, then its symbol should always take a capital letter, while the complete unit should always start from a small letter. And the fifth one is unit should always be in a single ratio. Ratio of ratio is not allowed. So these are the 5 norms for using SI unit system. Now our next topic is derived quantities and derived units. Derived physical quantities and derived units. Those units which are obtained from the fundamental units, are known as derived units, and those physical quantities will be named as derived physical quantities. Say for example, if we talk of velocity, then we know that velocity is defined as displacement upon time taken. What is displacement? So unit of displacement is meter and unit of time is second. So meter per second. So we have used meter and second. We have combined this unit. So this unit, meter per second, will be known as derived fundamental unit, and velocity here will be known as derived physical quantity. Right? So those physical quantities whose units are derived from the fundamental units are known as derived physical quantities, and their units are known as derived units. You can take any other example, right? We have taken velocity, you can say acceleration is meter per second square, right? Momentum, kg meter per second, There we have used 3 units, kg, meter and second. So kg meter per second will be known as derived unit for momentum. Okay. So these are the few examples of derived physical quantities and derived units. There are many more such examples which we will discuss later on. Now in this lecture, if we first recall or revise, we have discussed about the 4 types of unit system, and the 5th one is SI unit system. We have discussed about all those 7 physical quantities of SI unit system, their units, their symbol, right, and how to use, that is practical norms for using SI system. And the last topic which we have discussed today is derived physical quantity and derived units. Now in next lecture, we are going to discuss about supplementary units. There are 2 supplementary units, right? So what are supplementary units, that we are going to discuss in our next lecture, as well as we are going to discuss parallax method for finding large distance. That is distance between Earth and Moon, distance between Earth and Sun, right? So that matter we are going to discuss, and if possible we will solve few examples based on parallax method also. If time will be there, we are going to discuss in our next lecture about size of planet, how to measure the size of a given planet. All these data we are having, right? And that data is exactly correct. You can say that they are precisely correct data. So how we got those data? So that related to that we are going to discuss in our next lecture. Till then, as usual, keep on reading, keep on writing, and keep on preparing. Thank you.